Okay, sharing screen. Find the error in the student's attempt to convert r equals -5 sine theta into rectangular form. Okay. All right, so r equals -5 sine theta. Okay. So the equation is the rectangular form is x squared plus y squared equals r squared. That's the one you generally start from. I don't know if that's where the error is, but that's kind of where you know, I would suggest starting. X equals r sine theta. I'm sorry, x equals r cosine theta. I've done this in a while. Cosine theta. Y equals r sine theta. Okay. And that's where you get this. I mean, that's one of the ways you're moving between these. So the student does the following. They say the square root of x squared plus y squared equals -5 y over square root x squared plus y squared. How do they do that?
This one was confusing.
Yeah, so let's try to unpack it. So they -5 sine theta. Hang on just a second, please. Be right back with you. All right, I'm back. The r equals -5 sine theta. And so I think what they do here is they substitute in on this side, they're saying that r equals square root x squared plus y squared. So that's how you get this x squared plus y squared equals. And then sine theta, for sine theta, they're substituting in, it becomes y over square squared plus y squared. Okay, so imagine that comes from this, where if this is theta, this is x, this is y, and this is the square root of x squared plus y squared, then the sine of theta is the opposite over the hypotenuse. So that's where the sine theta comes in here, y over square root x squared plus y squared.
Okay.
Right. The issue I see is that when you solve this for r is equal to actually plus or minus square root x squared plus y squared. So that could be one source of error. So it looks like the next line, these find the errors are always really challenging. It looks like they just multiply both sides by the square root of x squared plus y squared.
To get it out of the denominator?
Yes. Okay. Left side, it goes away. The truth, though, is when you have the absolute value of something times the absolute value of something, it becomes, I'm sorry, the square root of something times square root of something comes to the absolute value of that thing. So on the left, it's the value x squared plus y squared. But okay, maybe that's not what they wanted either. So I'm still maybe because they somehow get a plus or minus here, and I'm not sure where that comes from quite yet. Okay. If they had done this correctly, where this was plus or minus square root of x squared plus y squared, as I wrote at the top right, the plus minus could come over here, but still not sure. And then they just move this over. So you get x squared plus y squared. And then when you move this over, it just becomes plus or minus on the left side. Because if it's positive, you subtract, you get the negative. If it's negative, you add and you get the positive. And that's this. So there's really two equations here. It's really x squared plus y squared plus 5y equals 0, x squared plus y squared minus 5y equals 0. These cannot both be correct. So that's probably where the error is. There's probably only one that's correct here. I don't think I helped, but maybe I clarified some of the conversion from rectangular form into non-rectangular form.
Yeah.
I can graph this and tell you which one's correct pretty quickly, but that's only if you want it. Or
I mean, I don't know that she would give us this, but it's okay. I think it's fine.
You need to know these conversions and this triangle over here.
Okay.
That has to be very super clear. Okay. What would you like to go to next?
Let's go to 9. I'm just gonna skip around here. 9.4. Number 5. Can we just go over, doesn't have to specifically be number 5, but like, can we go over like converges, diverges, that kind of thing?
Yes. Yes. All right. So let me snip number 5 in. Okay. Determine whether the sequence converges or diverges. If it converges, and some of these do, give the limit. The converges means that it approaches a value. Approaches a number, actually, we'll say it that way. Okay, so like I wouldn't have started with any of these, but like let's look at A. A is -3, -6, -9, -12, -15. Each time it's going down by 3. So if you're to like graph this, and that's probably a good place to start. The first point, wherever you want to consider it, there, and see how it's just going down forever.
Mm-hmm.
This one approaches -infinity. This one does not converge; it diverges. So infinity is not a number; it's a destination. If you see something that's either growing really large, positive or negative, then it diverges.
Okay.
So for example, let's just say you had a sequence like this. AN equals 0.1 plus 0.001 n. Okay. This one, if you write out a couple terms, the first term is 0.101, then 0.102, then 0.103, and so on, right? This one's growing though, like every time it gets bigger.
Uh-huh.
This one goes to positive infinity. And it still diverges because it does not approach a number. So even though it's really small, like eventually this will get to giant numbers.
So basically, it doesn't matter how small it gets, it just matters if it's negative or positive.
Yeah, if it keeps going. Like if it keeps going up and up and up, positive or negative, it diverges, okay? So that's kind of like case A. Now cases B, C, and D are these ones like B, for example. Let me snip B again. Let me snip. This question that they're asking you about is it's analogous to the following. So let's say I told you that f of x equals 3x plus 2 over 5 minus 2x, and I said, what is the horizontal asymptote? You would tell me, because you're a good math student, that it was 3 over -2. You would say it's this number over this number. And we could talk about why that is in a moment, but you would say it approaches -3/2, so this converges because it approaches a number. So when it approaches, go ahead.
Sorry, but why on the last? So the last ones, they were like continuing. Is that why they were divergent versus convergent?
Yeah, it's like this is the equation of a line. Like this one's, see, A is just given as a number. If we were to give it as one of these, it would be 0 minus 3n. And you would you would see, oh, well, that just goes down, down, down forever. These all have numerators and denominators, so they're slightly different
Gotcha. So for
types.
numerator and denominator.
Yeah. Okay, so let's review why this one converges. So rational functions, there's three cases. Rational functions. Okay, so the first case here is, call it case 1, and sorry if this is too small, make the font bigger, is if the degree of the numerator is less than the degree of the denominator. Okay, sorry if that's misspelled. Yeah, it is misspelled. Get that right. Okay, so what's an example of this? So an example of this would be like f of x equals 2x minus 1 over 3x squared plus 2. So the degree of the numerator is 1 because there's a 1 right there above the x.
Okay.
The denominator is 2. 1 is less than 2. You follow that? This 1 and this 2.
Yeah, so what does the 1 less than 2 mean?
It means that this thing approaches 0.
Okay.
Okay, so an example of that is letter C, and then we're going to go back and do B, but we got to do, there's
Wait,
kind of an order.
Can you talk about the horizontal asymptote, how you found, is it just the x's over each other? Is that what you did?
Well, what it approaches and the horizontal asymptote are the same thing. So the horizontal asymptote here is y equals 0. I need to just step away for 30 seconds, be right back.
No problem.
So the horizontal asymptote, I'm back. The horizontal asymptote of this function is y equals 0 because the degree of the numerator is less than the degree of the denominator.
Okay.
Let me just not show this one. So if this was 2n minus 1 over 3n squared plus 2, it converges to 0, which is the exact same thing. It's like in this world you say converge, in rational functions you say horizontal asymptote.
So for the one earlier, the first one that was done.
We'll go back to that one. We got to do C first. Okay. So what is the degree of the numerator?
2.
It's 2. What is the degree of the denominator?
3.
2 is less than 3, so this converges to 0.
Okay, so anytime it's less, like the numerator is less than the denominator, it goes to 0, basically.
Yes. Okay. All right, so now we're going to do case 2. If the degree of the numerator is equal to the degree of the denominator, okay, the horizontal asymptote, I'll just say HA, or the converging value, converges to value, is the ratio of the leading term coefficients. This one is like harder to type out than actually to do. So that's the one that we were just doing here. That was letter B. So the leading coefficient, see how the numerator has degree 1 and the denominator has degree 1?
Yeah.
Okay. So now it's the leading term coefficient. So this is written poorly because it's not written in the correct order. It's supposed to be minus 2n plus 5 on the bottom, and then it's the ratio here.
Oh, okay. So you just find like the x's or the n's.
Yes.
Okay.
Minus 3/2. Okay. And then there's case 3, which I got to go grab this one here. I don't think I didn't actually change this to 2. Let me do that real quick. And then case 3, you learn about these in calculus, but in a different way, is if the numerator is greater than the degree of the numerator. So that's what's happening in letter D. And these always go to either positive or negative infinity. So I'll write that here. So the numerator, the numerator has degree 4 and the denominator has degree 1. 4 is greater than 1. So this either goes to plus or minus infinity.
Okay.
And now how do we choose? Well, in your problems, I think it's almost always going to go to positive infinity, but like let's just say there was a negative here, then it would go to negative infinity.
What if it was n to the fourth minus 5? Would that affect?
This doesn't matter.
Okay, so just in front of the coefficient.
Yeah, so like here's something an instructor could do. They could say 0.00001 x to the third over 15,500,000 x. Okay. What's the degree of the numerator?
3.
And the denominator?
1.
So this goes to infinity.
Okay.
Because 3 is greater than 1. It doesn't matter what these numbers are. It doesn't matter what you could say plus, you know, 10, negative 10 to the minus 99. It doesn't matter. It has nothing to do with that. It's distracting.
And then if it was negative 0.001 x to the third, would it be goes to negative?
Yeah, it would.
Or converges to negative.
Converges. No, these diverge. These diverge. I'm sorry. Whenever infinity is involved, it diverges.
Oh.
Converges only goes to a number.
Oh, you're right. Yes.
Infinity is not a number. It's a.
Wait. So which one was the converges one? So not D.
Both case 1 and case 2 converge. So in terms of, let's go back and just do these real quick. Okay. A is diverges to negative infinity. B is converges to minus 3/2. C is converges to 0. And D is diverges to positive infinity.
Okay, so then when she says give the limit,
that's the limit.
Okay, so in limit notation, that would be like lim.
Oh, yeah. If that's what your instructor's asking you to do, yeah, let me do that. Okay, yeah, sorry. So here you'd say the limit as n goes to infinity, 3n plus 2 over 5 minus 2n equals minus 3/2.
Okay, gotcha. Okay.
That's what you're supposed to write out.
Okay.
Is there more that you would like to see on this?
Let me see. Just 9.4. Oh, can we do one where it's like you find the explicit term or whatever it's called?
Sure, the explicit formula.
Okay, it's like explicit versus, this is on the notes.
There's recursive, and then from recursive you can find an explicit formula sometimes.
If they gave okay, they did like an equals 3n, a to the 100 equals blank.
I didn't write it right.
Yeah, like that. That's what I meant. Sorry.
3n. It can't be n. I mean,
it's like an in like those swirly brackets.
Yeah.
And then like a colon, a semicolon.
Okay.
After the 3n.
Oh, yeah. I see. And then they tell you the 100th term. They want you to find the 100th term.
A subscript 100. Yeah.
Do they give you the first term?
No.
Okay. All right. So I got it here. Let me rewrite this. So they tell you that an equals 3n. What does n start at? Do they say? Should be like 1 most of the time.
It's on the a1. Oh no, they say a subscript 0 equals 0, a1 equals 3.
Yeah, a1 equals 3. Okay. All right. So the so a's when n, it's kind of a process here, like n equals 1, so a sub 1 equals 3 times 1, which equals 3. N equals 2 is a sub 2, which is 3 times 2 equals 6. N equals 3, I'll just one more time, a sub 3 equals 3 times 3, which is 9.
Okay.
Okay, so now you could do this forever, right? Or you could just say, okay, if I need the 100th term, it's 3 times 100, which is 300.
Oh, okay.
Now there's some of these though where it's like a n plus 1 equals 3 times a n, meaning the next term equals something times the previous term.
Right. Okay.
And we did this in the SAT review. We did this with the toy problem where you had to find the next year's number of toys.
Yes.
You've actually already done this, so you at least had some familiarity with it.
Okay. So then there's some more complex. Okay. So if they ask you like, oh wait, let me see.
There's only a couple of things that they can do if they give you a sequence. Like you
This
can.
one, okay, so this one was like more. So they gave you like an in those brackets equals 3 parentheses a subscript n minus 1.
Yeah.
Plus 2.
Okay.
And then a4 equals 6. And then they ask you to find a5, a6, a7, I guess.
Okay, great. So let me just put this out here. So you can, when you're given a sequence, you can always find a formula. You could be asked to find the nth term. Sometimes you're asked to sum terms, so on. So there's a few things we can do here. So this is a good problem here. This an minus 1 just means the previous. And then I like to think of it as current, but some people say next. I don't know, next, previous, kind of, sequel, prequel kind of thing,
Okay.
or prequel, sequel, whatever words you want to use. But they're in order here. So if n equals 4, you've already got the answer. So you wouldn't use that. You would say, okay, let me start at n equals 5. A sub 5 equals 3 times a to the 5 minus 1 power plus 2. If we simplify this, it's 3 times a sub 4 plus 2. Do you know a sub 4? Yes, that's 6. I think that's what you said. Yes. Mm-hmm. So you're just substituting these values. The hardest thing is you got to put 5 in there and then know to make it this a sub 4, and you already have that. So it's 18 plus 2, so a sub 5 equals 20.
Okay, and then you just do the same thing for...
Yes, a sub 6 equals 3 times a sub 5 plus 2. So you'll start seeing, oh, there's a pattern here. It's 3 times the previous one plus 2, which is
okay, gotcha.
62. So A7 is 3 times 62 plus 2. That's 186. So it's 188.
Okay.
So this is like they gave you the formula and we found the nth term in the formula.
Right. Okay. That makes sense. Okay, so for these, I'll just read it. AN equals ln3, or in brackets, in the swirly bracket things, comma, ln6, comma, ln12, comma, ln24.
Okay.
And then it wants you to state the common difference, provide a recursive rule, provide an explicit rule, and provide the 98th term.
Is this one of the questions that I can refer to?
Yeah, it's on the 9.4 notes on page 5.
Okay. Let me get back to that. Okay, I found it. Opening it up. You said on page 5.
Yeah, on the bottom, number 1.
Okay. You said state the common difference. Okay. This is a good question because it's not normally you get numbers and you subtract. Like the difference is natural log of 6 minus natural log of 3. But your instructor has done something here that it's kind of creative here. Natural log of 6 is natural log of 3 times 2, or 2 times 3. Maybe I'll write it that way, 2 times 3. So that becomes the natural log of 2 plus the natural log of 3 minus the natural
So
log of
then
3.
the natural logs of 3 cancel out.
Yeah, so while this is correct, it's not the right answer. The natural log of 2 is the correct answer. And you could do that for this next one if you wanted, but that's pretty good because it's another way you could do it here is you could actually use the property of logs where when you're subtracting, you divide what's inside. 6 over 3, and that becomes the natural log of 2. That's another. Either way works. Your instructor chose to do it the second way. I didn't see that at first. So that's the common difference. Great. Provide a recursive rule. So recursive rule, it's arithmetic. If it has a common difference, it's arithmetic. AN equals A1 plus N minus 1 times D. This is the known formula. It's actually just point slope form, kind of in a different form, but that's what it is. You got to remember that. So AN equals natural log of 3. That's your first term, plus N minus 1 times natural log of 2. So this is correct, but your instructor might want you to simplify this. I'm not sure. Really not sure. So how would you do that? Well, it's natural log of 3 plus natural log of 2 times N minus natural log of 2. So you can combine these two, natural log of 3 minus natural log of 2. You could write this as natural log of 3 halves.
Do they not just like subtract to like natural log of 1?
No, that's very bad. Very. Yes, don't do that. The only way you can subtract them is like we did. If you subtract them, it divides, as we showed over here on the right.
Okay.
So let me just finish. So I have no idea what your instructor wants for a final form, but it would be natural log of 3 halves. That's this, plus natural log of 2 times N.
The recursive rule.
That's the explicit rule. Sorry, explicit.
Oh, okay.
Yeah. It's odd to me that that's part C. You generally use C before you do B. Actually, I don't see B very often for these. So the recursive rule, let me snip in the sequence again. You have to look at it a little bit more visually and say, well, what's happening here in words? Like, how do you go from natural log of 3 to natural log of 6? Like that's the question you're asking. And then whatever you get there should be the same here. So how to go from natural log of 6 to natural log of 12? And we've already talked about this. You're multiplying by natural log of 2.
Okay.
I'm sorry. You're adding natural log of 2. Sorry. Because the natural log of 3 plus the natural log of 2 equals the natural log of 3 times 2, which is the natural log of 6. So you have to, and so well, how does that work here? Do I add natural log of 2? Well, let me try it. Natural log of 6 plus natural log of 2 equals natural log of 6 times 2, which is the natural log of 12.
Okay.
So that's now we haven't answered. What we've done is we figured out, well, how do I do this? So the next term, and I'll use AN, equals the previous term. And then whatever you're doing here, well, we're adding natural log of 2 to it. This is the recursive part. Like that's the thing we just figured out, the fact that you have to add natural log of 2 each time.
Right. Okay. But you still have to say the whole thing.
You still have to show all of this, but that's like what makes it recursive. Okay. And this over here, but alternatively, it could be written like this. It just depends on what you like. The other thing here is this one's good from n, like n greater than or equal to 1. This one is good from n greater than or equal to 2. So you have to be careful with that. Your instructor seems to care about stuff like that.
Okay. For the
Or you could start it, I guess you could start at 0. It depends. Okay, sorry.
I think that one is starting at 0. I don't know. She said like you need to state like where A is starting.
Yeah, and that's why you need these 1 or 2s in there.
Okay. For the recursive rule, or no, sorry, the explicit rule.
Yes.
She wrote like, these are my notes. Maybe I copied it wrong, but like she wrote like ln 2 to the n times 3 equals an for n equals 0.
Yeah, say that one more time. I didn't catch all that. I'm trying to get caught up here.
It was ln 2 like raised to the n power times 3 equals a subscript n.
Like that?
Yeah, and that was for n equals 0. And then for n equals 1, it was ln 2 to the n minus 1 times 3 equals a.
Okay, that's true. So this is an interesting one because you can actually do it either in geometric form or arithmetic form.
Okay.
So the geometric form, let me come down here and make some room. So geometric sequences, they have a common ratio, not a common difference, which is why it's a little bit, I'm not sure this one applies, but oh, well, yeah, I guess it does apply because of the way that you're doing here. So it's an equals a1 r to the n minus 1 power. And your instructor was said, okay, well, natural log of 3 is your first term. And then you said your r is 2, 3, 3,
Yeah.
3. And then you said to the power of n or n minus 1?
Is this for the n minus? Oh, this is for the n minus 1. Well, is this starting at 1 or is this starting at 0?
It doesn't matter. Let's start at 0. So then it's to the n.
Then it was n.
Okay, so an. So a0 would equal natural log of 3 times 3 to the 0 power, which does equal natural log of 3. So we're in good shape. So now we're going to do a1. a1 is natural log of 3 times 3 to the power of 1. And so this is 3 natural log of 3. And this is where it's not. This is where it doesn't work because your second term is natural log of 6. So if you bring this 3 up here, which you can do, it's natural log of 3 to the power of 3, which is natural log of 27. So there's something that isn't quite right about what you just told me. This one, I don't know that it can be written as a geometric series. So you may want to just.
So what was the way that you wrote it? Was that
Yeah, arithmetic.
Arithmetic. Okay.
Yeah, and that's this formula right here, a1 plus n minus 1 times d. You found your common difference. Your common difference is natural log of 2. Like I would probably just leave it like this because it's you don't know what you're going to do with it yet.
Okay.
But you can, okay, so maybe I do see what your instructor did here. So you can bring this exponent out in front.
Which exponent?
This n minus 1 becomes, let me just bring this down. We've got a little more room to work with it. Ooh, this is so unnecessary because it doesn't help your understanding, but I see why you got to do it. So the an equals natural log of 3 plus natural log of 2 to the n minus 1 power. So the reason you can do this is n natural log of x becomes natural log x to the n. This n comes up. That's just a property of logarithms. That's how this n minus 1 comes up here. Now, really, this is written as 2 to the n minus 1 power like that. So you can multiply these because natural log of a plus natural log of b is natural log of A times B. So you can actually multiply these. Your natural log of 3 times 2 to the n minus 1 power.
Okay.
And that's, I think, what you were supposed to write down. Somehow it got,
yeah,
it got,
messed up.
and then this does work. So like, you've got 1, 2, 3, you've got A4 is supposed to be natural log of 24. Let's see if it works. So A4 equals ln 3 times 2 to the 4 minus 1 power. 4 minus 1 is 3. This is 2 cubed. 2 cubed is 8. Natural log of 3 times 8 is
ln 24.
Yeah, so it does work. A lot of effort to get there, though.
Right. And so that would be a geometric.
No.
Oh.
No, it just was written this way, which it kind of looked like a geometric, but it's arithmetic because it has a common difference.
Okay.
So there's the language is really critical here. You have a sequence. There's actually several different types of sequences, but let's say it's arithmetic. You're looking for a common difference. And let's say it's geometric. You're looking for a common ratio. And this is like an plus 1 minus an. And this one is an plus 1 divided by an.
Okay. Okay. Makes sense. So then for finding the 98th term, you would just, so you have to use the 97th term, right?
No. If we want to find the 98th term, we've got this formula here. That's what's really nice about this.
Oh, so you just plug in to the n or whatever you plug in.
Yeah, I mean the issue here though is you can't. I don't think your calculator will do 2 to the 90 minus. No, I'm sorry. We're finding the 98th term. Sorry, 98 minus 1.
Is that
so this
an A or is that a 9?
This is an A. I'm sorry. Okay. A sub 98.
Okay.
But here you can break this apart again. Natural log of A times B becomes natural log of A plus natural log of B. So it's natural log of 3 plus natural log of 2 times 97, 2 to the 97.
Mm-hmm.
And then you can use this property where natural log x to the n becomes n natural log of x. So that n comes out in front. So this 97 is going to come out in front. So it's natural log of 3 plus 97 natural log of 2. And that is doable. Like if you had to give an approximation, you could do that, whereas you couldn't before.
But you could never do that like that wouldn't be something you'd be expected to do by hand. You put that in a calculator.
Yeah, that's a calculator. And sometimes what they do is they tell you like natural log of 3 equals 1.7, and then you have to approximate it. But I don't think you'll have to have that here.
She left it as ln 2 to the 97th times 3.
The calculator cannot do this step.
Yeah, I think she just wants it. I don't think she wants it completely simplified, I guess, maybe. Okay. Makes sense. Okay, this section's good. Let's see. Let's do... Oh yeah, maybe we should do one with some. Okay, so on the 9.5 notes, which
Yep, I got them up now.
On page 2, it's like do not use a calculator. So I guess any of these, maybe example 1 or.
Sure. So we're estimating I don't know why it says this. So we're trying to find the sum from n equals 1 to 100 of n. Is that what you're asking to do?
Yeah.
Okay, so there's a, this is, I mean, so there's the sum of an arithmetic sequence, this is only for arithmetic, is n over 2, first term plus the last term. It's like an average, basically.
Okay.
You average them and you multiply the number of numbers that are there. Okay, so you have to find the first term. You have to find the last term. That's why you need a formula. So this one is an equals n is your formula. And then you need to know the number of terms, and that's this up here.
That's the 100.
Yeah, so like this is a weird example, but the sum of the first 100 terms is, because it is the definition, that's why it's the word, 100 over 2, because there's 100 terms. The first term is 1 because a1 equals 1, and a100 is 100.
Oh, okay.
But this is a bad example. Like we did one earlier. Let me try and do one earlier. Find the one earlier we were doing. If there was one. Yeah, we were doing this one A. This one right here. Let's find the sum of the first 100 terms of this one right here.
Okay.
Because this is, I mean, you won't see this in your exam, but it's more of exam type question.
There was one like that on this same page of notes also, like halfway down there's an example like that.
Let's try this one. See.
Okay, so you do.
So the form. So let's change that. But let's do the first 10 terms, because that's okay. So your sum of your first 10 terms is 10 over 2. It's n over 2. A1. Sorry, A1. But you know A1 now. A1 is minus 3. So let me delete that. Minus 3 plus, you need the 10th term, which in this case is a sub 10. You need to find a sub 10. So how do you find a sub 10? You either keep going or you need a formula for this. So do you have a formula for this? I think we found that it was a sub an equals minus 3 times n.
Oh yeah. Okay.
Okay, so the a sub 10 would be minus 30, so that goes here. So this is 5 times minus 33, which is equal to negative 165.
Okay.
Now we can go to example 1 or 2 if you want.
Yeah.
Let's do example 2. It's a little harder. Snip, 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 snip. All right, find the sum of, express the sum in series notation. So the first thing is, can you write this as a sequence? Like, can you find the formula for an? An is a1 plus n minus 1 times d. Can you tell me a1 and can you tell me d for this?
Okay, so a1 be your starting term, right?
It's your first term.
So 111. Yeah, 111.
Yep. Your d is your common difference. So you can calculate it, or sometimes you can just.
111 minus 108. Okay, so just 3. Right? 3?
Yes, negative 3. I'm sorry. Yeah, negative 3.
Okay. Negative 3.
Okay. Yes, d is negative 3. So then you have this here. So this is needed for the sigma. So you're going from n equals 1 to something up here, and then this is it. So you probably want to simplify this a little bit. It's 111 minus 3n plus 3, so it's 114 minus 3n. Now, one thing you might notice here is that the you don't know this top number, but they tell you AN, like they tell you the last number in the sequence. So they're telling you like we're not giving you N, but we're telling you what it is. So they're actually giving you 27 is AN, and you have to solve for N, and that'll tell you what number goes up here.
Okay, so you add the subtract the 114. 27
Yep.
minus 114, which is, I don't know.
So what, 87 equals minus 3n, so n equals like 29, we'll say.
Oh, that's how, okay, that's a good comment.
Okay, and that's how you come up with that number. So that's the express the sum in series notation. To actually find the sum, it's probably not that bad. It's the sum of the first 29 terms. Okay. And the 29 terms, so it's 29, that's n over 2. So it's n over 2. First term, which we were given, was 111. And then your last term was 27, I think. And then you just perform these steps here.
Oh, okay. It's not terrible. And these are still, yeah, these are arithmetic. I don't know how to say that word. Whatever sequences.
Yeah. So this is this lot here. Your notes are pretty good. Like maybe what you're missing is like the explanation that goes along with the notes.
Yeah, that's kind of my issue.
Does your instructor record their lessons, or are you in person?
No, I'm in person.
Okay.
Yeah.
All right. Well, I mean, you're not that far off here. Just I guess I would keep trying. When's your exam?
It's on Monday, but she hasn't even made it yet, so
okay.
She can't really tell us what's on it.
All right. Well, let's see. So we're all done for today. I mean, I think you could obviously schedule again if you want, but you probably have enough here just to, it's going to be kind of the same stuff.
Okay.
Again, I've got some times on Sunday if you need it, but usually you do pretty well, after we do a couple of sessions like this.
Yeah. So I'll just keep studying the notes and do the review for sure. And then if I need one, I'll sign up on Sunday.
Sounds good. Okay, I will send you the notes and the screen recording out shortly.
Thank you.
Okay. Bye now.